Okay, so in preparing for the final exam for biology, you will need to remember a couple of important things. First thing, level of detail. Okay, when you are explaining something or when you are demonstrating an application of your knowledge and understanding of a concept, demonstrate. Okay, don't assume, Mr. Coderre knows I know this. I do know that. But unfortunately, I have to have proof that you know it. And that proof comes in the form of you writing a very long, detailed answer full of all of your knowledge and understanding. Okay, if you only write, it's phototropism because it's light. That's showing me 2 out of the 5 things I know that you know. And I can only mark what you show me. Okay?
Like, let's say on a written response, you write like a bunch, but you accidentally say something like that wasn't even close to what you were talking about. Are you getting a mark off? Or are you just
Only if it contradicts you.
Okay.
So if you say, like in a tropism question, so this plant is clearly showing phototropism because the light source is over here and it's doing this and blah, 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 but it could also be thigmotropism. Well, then you clearly don't know what you're talking about because you're saying it's 2 different things that are caused by 2 entirely different things. They would look nothing alike. In that case, you've said too much.
Got it.
Yeah, but other than totally contradicting yourself in a way like that, no, you can't go wrong by saying too much. Okay, like if you end up you're writing in there and something you say is not really applicable, I'm going to go, okay, well, I'm not going to dock a mark for that because it's not necessarily wrong. It just doesn't really apply. Okay, so as long as you don't contradict yourself, you're better off to write a lot. Okay, yeah, and no circular logic. Okay. All right, so yeah, level of detail, really important. Okay, so if I give you a picture of a plant, let's say that's growing clearly towards a light source that's off to one side, okay, you would say, as a level of detail question, rather than saying it's phototropism because of light, which is 2 out of 5, you would say this plant is clearly showing phototropism. Its light source is off to the side. The plant's shape is changing as a result of auxins being secreted to one side of the plant more than the other, causing it to curve towards the light source, which is, after all, its food. Okay, and so this would be an example of a differential rate of growth on 2 sides, causing a change in shape of the plant. Now you've said 5 marks worth of stuff. Okay, because you told me not just that it was phototropism caused by light, you've told me how all tropisms occur. Okay, and that's important. Okay, we need to know that stuff. Okay, I need to know that you know that. I know you know that stuff, but you have to show me and put it on paper so I have a record of it. Okay, all right. So important concepts, cell theory. Okay, that could definitely be something that shows up in the multiple choice. There are 3 points to the cell theory, so it'd be really easy to make a multiple choice question. Which of the following is not part of the cell theory? Okay, or something like that. So know that point number 1: all organisms are made of cells. Okay, cells carry out the basic functions of the organism. That one you could probably work into a number of written response questions as well. It's just one of those things that say, Coderre, I know that cells carry out the basic functions, and this is one of the basic functions, and I'm working it into this answer. If it's about like diffusion or osmosis or something like that, you can work that into a question about cell transport for sure. And then the 3rd point is that all cells come from the division of existing cells. Okay, so we know that stuff. We write it all down. Okay. All right, and then we talked about modes of nutrition. I'd say that's the next most important thing. Should you know the 2 words? What are the 2 words?
Chemoheterotroph and photoautotroph.
Chemoheterotroph, photoautotroph. Okay, photoautotrophs use photosynthesis. Okay, they can make their own food using light. Chemoheterotrophs have to consume the organic material from other organisms, living or dead, okay, for food. Okay, chemoheterotrophs will have what organelle that photoautotrophs will not? Lysosomes. Photoautotrophs will have chloroplasts. Okay, because they've got to carry out the photosynthesis. Okay, so little things like that, right? Like those are details that are important. Okay, if we're saying, look, I understand that this thing is a chemoheterotroph because it eats other things, and it eats other things because it needs organic material from other organisms. It has these organelles to do it. Its cells wouldn't have a cell wall. All that stuff. That's level of detail, right? All right, so modes of nutrition, okay, why there's structural differences, cellular structural differences, okay, that would be probably multiple choice stuff. And then cell diagrams. You're definitely still going to have to label the parts of a cell or tell me the functions of the parts of the cell, but I will tell you that on the final, those come in the form of several multiple choice questions. Okay? It will not be a written response question with a chart like there was on your unit exam. Okay, and then lesson 5 was all about the parts of the cell and what they do. Okay, so you still need to know that, because in a multiple choice question I can say, which structure would be responsible for detoxifying poisons? And you would have to go in and find the smoothie R. You need to know that that's what the smoothie R does in order to answer that question. Okay, and then cell transport. Cell transport is big because it was not only part of the cellular part, it was also part of the transport in plants part. Okay, so expect that cell transport will be in both parts of the test, some multiple choice and some written response. And there were a lot of application style questions on your unit exam about cellular transport. Expect similar types of questions. Okay, like I think on one of the questions it was the cartoon of Garfield. Okay, with the books being squeezed, and he said he was learning by osmosis, and we said, well, that's not really the way osmosis works, because osmosis only transports water. Okay, does it across the cell membrane in response to differences in concentration. Okay, knowledge in a book doesn't certainly work that way. Okay, the only thing he's really got right is that there's increased pressure on the outside and less pressure on the inside. So maybe there's something to that, but okay, other than that, no, it wouldn't work. And that's you demonstrating, Mr. Coderre, I know that osmosis is the transport of water passively across a membrane to balance salt concentrations. Right? You say all of those things, that's level of detail. Okay? All right. What were the other two? Osmosis, diffusion, active transport. Okay, we've got to know all three. Okay, all three were on your unit exam. Obviously, I don't have room on the final to test all three in the written. Okay, they'll definitely all three be on there, but there could be more than one in the written response. Okay, definitely know them well enough to be able to identify and explain. All right, cell size and transport. So the cube activity that we did on your unit exam, you were comparing two cells. Oh no, it was the Starship Enterprise. That's what it was. And it was asking you why an amoeba couldn't get that big. Okay, and you had to talk about how as a cell gets bigger, its surface area doesn't get big as quickly as its volume, and it has to transport by diffusion through its volume, and diffusion is slow and not targeted, and because of those vast distances, it wouldn't get things where it needed to go in time, and the cell would die. Okay, again, that's demonstrating, I know this is what diffusion does, I know it's down the gradient, I know it's slow, I know it will cause this and this, that's level of detail. Okay? How many times have I said level of detail today? I'm hoping I'm getting that to sink in. Okay. All right, multicellularity was another one. Okay, and specialization. All right, so a true multicellular organism has different groups of cells that do different jobs. Our example in this class was the layers of the leaf. Okay, I would say that I would probably put that on the final. Okay. Probably more in the multiple choice, but it's still something we need to know. Okay, and remember that all multicellular organisms are eukaryotic, because in order to be specialized, cells have to have those different compartments and things like that, so those kind of go together. Okay, and then we got plant structure. Okay, roots, leaves, stem, okay, the parts, what they do, okay, probably multiple choice for that. Okay, but definitely know the leaf layers, and we've already talked about that. Know the stomates, they're another example of cells specialized to do a certain job, and on top of that, their special job has to do with not only the conservation of water, but also transport of water, because if they're not open, we don't create that osmotic pressure by having water evaporate through them. on the note of plant transport, is that something that's gonna be on here? Definitely. Should you know xylem and phloem? Should you know what causes water to move up a plant? Which I just said, which is what cell transport process? Osmosis, yeah. Okay, water evaporates through the stomates, salts get left behind in the spongy layer, water moves towards the salts by osmosis, it's passive, plants can't control it, it just happens. Okay, that creates that osmotic pulling action because water is a polar molecule, it's bonded, hydrogen bonded by cohesion and adhesion all the way down the stem in those narrow, tiny xylem tubes, okay, that allow the plant to do that. That's something you're definitely gonna have to know well enough to explain likely in a written response question. Okay, so definitely go over that one. Okay, that's a big one. Level of detail again is important. So there you go. Plant transport, polar nature of water, xylem, phloem, osmotic pressure. Okay, all that good stuff in both sections of the test. All right, the next concept that's going to be on there was plant growth and development. Okay, so that's the hormones. There could very easily be multiple choice questions about the hormones, just like there was on your unit exam. Okay, so that's auxins, cytokinins, gibberellins, okay, abscisic acid, ethylene. Okay, what do they all do? Okay, what are their roles? Right, things like that. So make sure you go over those, okay, because they could definitely be on there. And of course, auxins are part of what makes tropisms happen. Tropisms is part of plant growth and development. So definitely know, okay, those ones, right? So know the hormones, there they are. Okay, auxins are part of tropisms, photo, geo, and thigmo. Okay, tropisms are the result of differential growth. Okay, auxins on one side, cells get longer on that side. Okay. Be sure you can explain that. On your unit exam, that was the picture of the tree growing out of the side of the cliff. Okay, expect you'd probably get a picture for a tropism question. Okay, and then you'd have to explain the picture. Okay, and microscopy. There's a little bit of stuff in there on microscopy and being able to estimate the size of an object. Okay, we talked about that in class. Oh, still have the slider up. Okay, so if I see this through the high power lens of my microscope, and I'm being asked to estimate the size of one cell, each one of these is a cell, okay? And I know that it's 400 micrometers from one side to the other. What would be a good estimate? Let's say it was a multiple choice question and these were your options. A, 400 micrometers. B, 300 micrometers. C, 200 micrometers. D, 150 micrometers. Which one would be the best estimate? D, yeah, okay. There's more than two of them fitting across, okay? That means they don't take up half, they're less than 200, okay? So 150 would be the best estimate. Okay, that's what there is. Okay, that's what's on the final exam in terms of biology, only the most important concepts. Okay, so some of the smaller details, okay, are not going to be in there, right? But make sure you go over those things. Okay. Now, when we're studying for chemistry, we study by practicing. Okay? We practice naming compounds, we practice writing equations, we practice balancing equations, we practice mole equation calculations. Okay, it's all skills. how do we study for biology?
You read it.
You read it, okay? Now, don't just read it, because you'll get bored and your mind will switch off, okay? When you're reading it, okay, so if you're reading about how thigmotropism happens, okay? Stop when you're done reading the facts and then think, how would Coderre's warped mind make a question about this, okay? And see if you can think up a way that I might ask that. If you can do that, you really understand the concept, okay? So, how would Mr. Coderre ask a question about thigmotropism? He'd probably show a picture of a plant growing up a fence, okay? And say, you know, what type of growth is this plant showing? And you'd have to say, well, it's using thigmotropism and allows it to support its weight using something other than itself, and it does this by wrapping its tendrils around the fence. And the tendrils wrap around using auxin secreted to one side, so one side grows faster and causes it to curve, blah, 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 okay? Level of detail, okay? So that's the kind of thing you want to do for biology. Yes, you need to know the facts, but remember, very few of your questions are going to just be about regurgitating the facts. It's going to be applying the facts to something, okay? So that's what you have to think about when you're studying. How could Coderre ask me to apply this? Or where is a situation where this applies? Maybe one that Coderre has talked about in class, okay? Think about that. That's the best way to approach that, because a lot of people get caught up in the trap of biology is read, remember, regurgitate, okay? It is the 3 R's in a lot of situations, okay? But we want you to also be able to apply it, okay? Or evaluate something with it, okay? So make sure you're thinking of it in that regard, okay? Questions for bio? Okay. Anything you want me to cover in more detail or go over a little bit more? Then, let's look at physics. How do you study for physics? Practice. Okay. You've got lots of problems with solutions, okay, in your workbook, okay? But another really good place to look for problems with the full explained solutions is not just in the lessons where I taught that material, like work energy theorem, acceleration, and conservation of energy, you know, where we had lots of problems we went over in class and I recorded the solutions. The other place is your quizzes. Okay? If you go into Power School on your phone and you tap on a quiz and open it up, okay, it'll give you the details about the quiz, and then there's a little box underneath that says notes. And in that set of notes is two links. Okay, one link says quiz 5 questions. If you click on that, it's the PDF I posted on Google Classroom, okay, the night before your quiz. And the other one says quiz 5 solutions. If you click on that, it takes you to YouTube. And it takes you to me recording myself going over that quiz, showing the solutions, okay? So if you want a few extra questions here or there that actually have the solution so you can totally check if you did it right, that's not a bad place to look. Okay, and the reason I say that's not a bad place is the guy that made up those questions is the same guy who made up your final. Okay, and he's not very creative, so he'll probably ask very similar types of things, especially when it comes to work energy theorem and conservation of energy and acceleration. Okay, so have a look at those. If you've done so many that you're running out and you still want more, that's probably not a bad place to look. Okay. All right, types of energy. Okay, that's going to be multiple choice, right? So, solar energy, chemical energy, mechanical, kinetic, potential, electrical, magnetic, okay, those things, that's just going to be recognition. I give you a question that says, what type of energy would would wind have? Well, wind would be mechanical or kinetic or something like that. Okay, and you need to know the laws of thermodynamics. Those are big because we talk about them not only in this unit, but also in Unit 4. Okay, so first law is the law of conservation of energy, and the second law is the law of direction of heat flow, always from hot to cold or high to low. Okay, that's, you know, there's probably ways you could work those into some of your written response answers, more so in your unit 4 with this, with the second law, okay? But there'll definitely be some multiple choice questions about those, okay? And probably systems as well. Easy to have a multiple choice question about open, closed, and isolated systems. That's just read over the notes so you know the difference. Okay, your heat engines and heat pumps, they're just examples of the laws of thermodynamics. Heat engines use the laws of thermodynamics. Heat pumps go against it. Okay. Okay, and then scalar and vector quantities. Okay, you need to know which things we talked about are scalar and which things are vector. Could be a multiple choice question about that, you know, but more importantly, exactly the way that so many of us got burned on that acceleration question on the unit exam. Okay, what's the final velocity? And I wrote downhill on like 90% of papers. Okay, that's where we don't want to forget what things are vector and what things are scalar. Okay. What things are scalar?
Direction.
Nope, things that are scalar only have magnitude, not direction. So the vector quantities are the ones that have both. So what are some things that would be scalar then?
Speed,
Speed,
distance,
distance, time,
velocity.
velocity's vector. Yeah, speed's the one that's scalar. Okay, mass also has no direction. Okay, and energy and work, okay, are all scalar quantities that we have talked about. Right, our vector quantities then would be acceleration, velocity, displacement, force. Okay, now we don't use force very much, but it is a vector quantity. Okay. So important to know those. That's going to be important in the written response. Okay, and then of course using v equals d over t and v equals d over t. Okay, that one's the scalar one. Speed is distance over time. Velocity is displacement over time. And that displacement can be calculated final position minus initial position. Very important if you have a position time graph. Now, on your unit exam, did you have one written response question for each type of graph? You did. Will you expect to see at least one in the written response section of your final? Or should you expect to see the other one? In the multiple choice, yeah. There's going to be some graphing in the multiple choice, there's going to be some graphing in the written response, okay? So you still need to know all those skills, right? It's just not as much in the multiple choice. But since you don't know which one it's going to be where, okay, you got to be ready. All right, and then acceleration, okay? We had the formula, expect some problem solving in the written response for acceleration. Okay, just like you had on your unit exam, nothing different. Okay, what are some tricks I can try and play on you in an acceleration question?
If it's zero.
Yeah. Yeah, if it's zero, you might cross something out, and if it's zero, it could be something being dropped, okay, or something like that, right? If it's dropped, its initial vertical velocity would be zero, and its acceleration would be gravity. Yeah. Okay, and I wouldn't put that in the question, right? I would say it's dropped, and that's it. I might say it falls for 10 seconds, right? Well, yeah, you got to know then that it's falling because of gravity. I can look up gravity on my formula sheet. I don't have to remember it's 9.81, but I have to remember that it's involved. Okay, little things like that, right? Those are the little tricks that I can try and play on you, and I probably will. Okay. All right, so definitely have acceleration in the written response as a problem-solving question, and then graphing. Okay, reading and interpreting. That's going to be more multiple choice. Okay, could be in the written as well. I'm not gonna, rule that out. But definitely it lends itself to a multiple choice question. And then extrapolation. Extrapolation means being asked to calculate a value not found on the graph, okay, or not readable from the graph. Okay, that means using y equals mx plus b. Okay. How will you know if you're supposed to use y equals mx plus b to answer a question?
The question will explicitly tell you.
It may explicitly tell you, or it may use those three words. Using your graph and the equation given with it, okay, or just using your graph, okay, rather than, oh, I'm just gonna use v equals d over t here. Okay, if it says using your graph, use your graph. Okay, another way, the graph has the equation on it. Okay, if it's one of those graphs that goes all over the place and isn't one single function, you can't use y equals mx plus b for that. Okay, but if it's one straight line, you can probably expect you're using y equals mx plus b. I would not bother to put the formula on there if it wasn't going to be used. So if you see that on there, you should use it, okay? Okay, and then we got position versus time, okay, graphs, and we can read off of a position versus time graph, position and time. Okay, we can tell what kind of motion is going on by the shape and direction of the line. Okay, if it's horizontal, the object is not moving because its position is not changing. If it's angled upwards, it's traveling at constant velocity forwards. If it's angled downwards, constant velocity backwards. Okay, if it's curved, it's accelerating. Okay, because then its velocity is changing, right? Constant velocity still means a straight line. Okay, acceleration means velocity is not constant. Velocity is also changing, so then we get a curve. Okay, if we have a velocity versus time graph, okay, and it's a flat line, what's the object doing? It could be not moving if the line is where?
Zero.
At zero, yeah. If it's a straight horizontal line along the x-axis, absolutely right, it wouldn't be moving. If it's anywhere else, the object is not accelerating, moving at a constant velocity, either forwards if the line is above the x-axis, or backwards if it is below the x-axis. If I get a diagonal line on a velocity time graph, what's going on? It's accelerating, yeah, either positively or negatively. Okay? If it's accelerating negatively, is it necessarily moving backwards? Doesn't have to be. Could just be slowing down. Okay? And same for accelerating positively. Could still be moving backwards. Could just be slowing down, moving backwards.
When do you have to put the negative or positive in your answer?
Basically, if it calculates out that way. So if I had a velocity versus time graph that looked like this, and it asked you to calculate the acceleration, okay, and didn't give you the equation, then you would use your final velocity, your initial velocity, and you would divide that by the time. Because this is a negative number, you'd be subtracting a positive number, which would make it more negative. Okay? When you do the calculation, it'll come out negative. Yeah. Okay. If you're doing the displacement, so for this part of the graph, the displacement would be positive. So v, okay, like the height would be positive, but here the height would be negative. So again, it'll come out negative when you do the math. All right, ringing a bell for everybody? Okay, those are the things I asked you to do in class. They're the things I asked you to do on the unit exam, so expect. I'm gonna ask again. Okay, and the reason we ask that stuff so much is because it is such a huge part of Physics 20. Okay, graphing is a big part of Physics 20, and even more so in Physics 30. Okay. All right, if I have a position versus time graph and it looks like this, okay, how would I calculate the average velocity?
Like we calculate all the math and all that and then
would do that for speed. Yes, I would do that for speed. But if I want to calculate velocity, it's actually quicker.
Just go to
Right? Final position, that would be this number here, minus initial position, this number here, divided by time, that number there. Okay, and I would have the overall average velocity. Now, if I wanted to calculate the average speed, then Maddie's right, I would go, here's the distance, here's the distance, here's the distance, here's the distance, add them all up and divide by the total time. Okay? Okay, if the graph looks like this, and I ask you what the average velocity is, how many marks is that going to be out of? Because I'll also put on there this equation, and it'll be m. It'll be the slope. Okay, little things like that. Okay, those can all come up. That's an easy. That's a multiple choice question. Okay, it's a 1 mark written response question. On a final, I'm not going to have too many 1 mark written response questions. Okay, like marks are at a premium. Okay, so expect that could be a multiple choice kind of question. Okay, so yeah, displacement. Okay, so we did that. Distance, add all the sections together. If we're looking at a velocity versus time graph, okay, this would be showing acceleration. We talked about that a minute ago. This would be showing the object doing what? Constant velocity. Okay, if I've got this graph here, the slope represents the acceleration because that was change in velocity divided by change in time instead of change in position divided by change in time as it was on the other graph. Okay, if I ask you to calculate the total displacement from this graph, how would you do it?
Find the area.
Find the area under the line. So you have like this one big rectangle and that triangle, or that triangle, that little rectangle, that big rectangle, whichever way you want to do it. Okay, find the area underneath the line. That's average velocity times time. Okay, same for this graph. Okay, you would have a rectangle and a triangle that you would have to calculate the areas of. Okay. Oh, and there we go. There was the example of it. Okay, work energy theorem. Did we spend a lot of time on that? We did. Okay. Probably the most important concept in Science 10 physics, maybe high school physics. And it comes up over and over and over again. All right, so work energy theorem. We know that work is being done if mechanical energy, either potential or kinetic, is being changed. Okay, at least in Science 10 it's or. Okay, in Physics 20 it's and or. Okay, but in this one you'll only ever have questions where either potential is changing or kinetic. How do you tell?
Height or speed or velocity.
Right, either height or speed is changing. Okay, if speed is changing, what kind of energy is changing? Kinetic. Okay, if height's changing, it's potential. Okay, and they all set up the same way. Right, now there could be some multiple choice questions about the understanding. They wouldn't involve any calculating. Okay, so that could be one like, here's a situation, what type of energy is changing in here? What the work is changing, what about this object? Kinetic energy, potential energy, okay, chemical energy, or whatever. It could be a multiple choice question. All right, but there's definitely going to be written response question. Okay, work is force times distance, which is the change in energy. Work is the final minus the initial, whether that's kinetic or potential. Okay, potential is m times g times h, and kinetic is 1/2 mv squared. You do not have to memorize those. Okay, they are on the back of the formula sheet. But what throws people with work energy theorem is that the combined formula is not on the formula sheet. Okay, work energy theorem involves combining the formula for work with these energy formulas. Okay, so when we say force times distance equals energy final minus energy initial, okay, if we're talking about a kinetic energy situation, that would be 1/2 mvf squared minus 1/2 mvi squared. Is force times distance. You don't see that formula anywhere on your formula sheet because it's a combination of more than one formula. All right? And that's, like I say, what gives people trouble often with this stuff. And then conservation of mechanical energy, okay, the contexts that we did those in, like, you know, kids going down hills on sleds, or things rolling down ramps, or roller coasters, okay, things of that nature. Okay, in those questions, no work is being done. The initial energy and final energy are equal. All right, and so that's where we have to look at, okay, do I have initial potential and initial kinetic? Do I have a final potential and final kinetic, or any of them zero? Okay, and then set those formulas equal to each other. It's another one that's tricky because it does involve you having to combine several formulas. Okay, you're not going to find a formula for this on its own. Okay. All right, so we have to remember things like, okay, mechanical energy is potential plus kinetic. That goes on each side. Okay, so that would be EP initial plus K initial, EP final plus EK final, okay, and then putting in the formulas for each of those, isolating whatever you're supposed to solve for, either a speed or a height. Okay, see if you remember how to do those. Okay, so on this one here, we have a 20 kilogram box, 20 meters above the bottom of a hill, moving at 4 meters per second. A little while later, it's moving at 10 meters per second. How far above the bottom of the hill is it? Give you a few minutes on that. Okay, so we'll use the initial setup here. I have both kinds of energy, potential and kinetic, at both positions. All right, so I'm gonna go with this and say, I'm looking for something that is part of the final potential energy. So I want to isolate that right now by doing what with the final kinetic? Yeah, subtract it over to the other side. Okay, so I'll have initial potential plus initial kinetic minus, okay, final kinetic equals final potential. Right, now at this point I can put in my formulas. M times G times H initial plus 1/2 MV initial squared minus 1/2 MV final squared equals M times G times H final. All right, what can I cancel? I can take out the mass. I don't have to, they gave me the mass. I can put it in for every M if I want to, but I don't want to. Okay, so I'm gonna take out the M. And then I just want to isolate HF. What do I do with G? Divide both sides by. And do I have to square root? H isn't squared, so I don't have to square it. I just divide by G. Okay. So what I'm going to have here is 9.81 times 20 plus 0.5 times 4 squared minus 0.5 times 10 squared divided by 9.81. Okay, so it should be 15.7 meters at the next spot. Okay, is that ringing a bell? I guarantee you one of those is on the file. Okay. Oh, there's the solution. Okay. Efficiency, there might be one multiple choice question about that. Okay, what would you guys like to ask or go over? Anything from the course? Anything you'd like to see demonstrated or have me review a little bit?
Chemistry,
Okay, like what?
predicting and balancing.
Predicting balancing, okay. Okay, let's try those three. We did 3 yesterday, out of the 5. The other 2 that we didn't do are on this list, okay? Plus one's a repeat. Okay, give you a couple minutes on those. There's the answers, okay. What else?
Can we do some mole equations?
Mole equation, sure. Okay, give you a minute on that one. All right, so we know the number of molecules. Okay, and we know that it is 7.38 times 10 to the 24. Okay, we also know that it is sodium nitride, which will help us get our molar mass, not sulfide, sodium nitride. Okay, I've got to drop and swap this. This is a -3, that's a +1, so I'm looking at Na3N, so 22.99 plus 14.01, okay, for 1 nitrogen. So we're looking at a molar mass, 22.99 times 3 plus 14.01, and 82.98 grams per mole. All right, so we've got our molar mass. Okay, if I want to find mass, I need the number of moles. Okay, I have the molar mass, but I need the number of moles. Since I have the number of molecules, and I know that Avogadro's number tells me the number of molecules in 1 mole, okay, I can find the number of moles. I simply take my number, the number of molecules, and I divide it by the number of molecules in 1 mole. And that will tell me the number of moles. Okay, so I take 7.38 E24 and I divide that by Avogadro's number. All right, so we are looking at 12.26 moles. All right, now that I know N and big M, I can calculate little m because N equals little m over big M. So if I want to get little m by itself, I simply multiply the other 2 numbers together. So that'll be 12.26 times 82.98. So I take those numbers, that one, and I multiply it by that one. And I have a mass of 1,017.26 grams. Okay.
How did you do the times 10 on the
Oh,
calculator?
in my calculator? Okay. So in order to put something in like this, okay, I go brackets and I go 7.38. Then I hit the second function and I hit the EE button. So the comma. Okay, and then 23. Yeah?
Okay.
Right. If your calculator doesn't have the EE button, then you look for an EXP button. Okay, that will also do the same thing. All right. Any other stuff we want to go over? Because we still got about 14 minutes.
The graphs and physics.
Graphs and physics. Okay. I think I even have a graph somewhere. Somewhere I have a graph. I know I saw one. Oh, it was in my physics one this morning. Okay, let's see here.
Okay, there we go. So there's a velocity versus time graph. Let's say I would like you to calculate the following things. Acceleration between 7 to 12 seconds. And the displacement between 0 and 7 seconds. Right, so question number 1 wants to know the acceleration between 7 and 12 seconds. All right, so 7 seconds is right here, okay, and 12 seconds is obviously the end of the graph. Right? If I want to calculate acceleration, acceleration is final velocity minus initial velocity divided by time. Right? Between 7 and 12 seconds, there are 5 seconds. Okay, so I know that the time is going to be 5 seconds. All right? The final velocity is 12, negative 12. Sorry, not negative 12. Well, let me take that back. Oh, no. I just want to erase this. Just let me do what I want. Okay, is negative 15. Sorry, not negative 12. Negative 15. And the initial velocity is 10. All right, so if I go negative 15 minus 10, I get negative 25, okay? And I divide that by 5, and I'm going to get negative 5 meters per second squared as the acceleration during that time, okay? Which fits with the shape of the graph. It is a negative acceleration during that time. All right, and then the second part, the displacement between 0 and 7 seconds. So we're still going to this point right here, but now we're finding displacement. I would say quickest way, these 2 shapes. Oh, sorry, these 3 shapes. All right, we got 2 rectangles and a triangle, okay, that will get us the total area underneath the line. All right, so this rectangle here is 7 on the base, and it is 4 high, so it is 28 meters. All right, this triangle here runs from 2 seconds to 5 seconds, so it's 3 on the base, and it goes from 4 to 10, so it's 6 high. 6 times 3 is 18. It's a triangle divided by 2. We got 9 meters in there, and then we have this rectangle here that goes from 5 to 7 seconds, so it's 2 on the base, and it goes also 6 high. So 2 times 6 is 12, divided by 2 is 6 meters. Okay, and now we've got all of our distances there, so we're looking at 45, no, we got 15 plus 28, so we're looking at 43, yes? 37, yeah, 43. 43 meters positive as our total displacement during that time. Okay, everybody all right with that? Okay, those are the kind of things that are going to be on your final. Okay, also be able to do something like this. What is the object doing between 0 and 2 seconds? Traveling at a constant velocity, yeah. Okay, and I would say be detailed. Forwards, okay, if you can tell me what it is, 4 meters per second, level of detail, right? Okay, in this part it's accelerating, okay, positively, right? Something like that. So just those little things, okay, all those things could definitely be on there. Great question.
If you were to put positive, you need to do a number.
Yes, if it asked for displacement and you didn't, you'd lose a mark. It said distance and you put a positive or negative. Guys, there's not really an opportunity to see each other before the final exam. Exams are being written in my classroom. Okay? So if you have questions while you're reviewing, okay, you have 2 options. Obviously, there are no exams being written between 11 and 1. So if you happen to be here for another exam, you can pop in on me, okay, and
between 11 and 1, I'll try to be in my classroom and answer questions. Okay, or you can email me and then I'll do my best to get back to you. Sometimes it's hard to answer questions by email, but it's what we got because we just don't have a lot of time. All right. Remember that I did post full unit reviews for the final exam last week, along with the exam review package, so you can always look at that as well. Okay? All right, it's been a pleasure to teach you guys, okay? And I hope you all have good luck on your finals and a good, nice, restful summer.